get started on some Code Wars today. Happy Friday. I hope everyone's having a great day. Okay, let's do some fun stuff today. I'll do it here because I have a lot of tabs for other stuff there. This one sounds so familiar for some reason. Okay, we'll do... Okay, so we have a 7 and a 6. Let's do an 8. Is there an 8? Okay, we'll do this one. Okay, so complete the function that takes two integers a and b, where a is always less than b, and return an integer or return an array of all the integers between the input parameters, including them. So including a and b, that's what it's trying to say right here. So let's go ahead and try to do this in Python. So okay, so we're gonna receive two numbers where a is always less than b. We need to return a list back of all the integers between. Hi Elder, how are you? Thank you for dropping a lyric. Hey, happy Friday. That sounds good right now. Fried egg. I'm a big fan of eggs, except the prices for eggs right now, but big fan. I hope you've been well, Elder. Let's see. Okay, so return a list back of all integers between a and b, including a and b. So if I have a list of 3 and 4, then I anticipate a list to come back of 3 and 4 because there's no other numbers in between them. So, let's see how I would go ahead and do this. What I would do is I would return every nums between a and 4. A and b. Sorry, I was thinking 4. 4 is b in my mind. So I return every nums between a and b. And since I know, I'm gonna go ahead and get... Hi Richard, long time no chat. So happy Friday. Any big plans for Friday? So yeah, so we're gonna return every nums right between a and b. And since I know that it's gonna be a list comprehension that I'm returning back, I am gonna go ahead and say return, and I'm gonna say a list, and I'm gonna say that let's see. Okay, so the way you write list comprehension is that you're saying return the num for range a b plus 1, and the reason why you have to do b plus 1, oh how fun. Yeah, so hope there's a lot of stuff going on, so yeah. So I'm gonna do a range function, and this will grab me everything from starting at the A all the way to B. But I do B plus 1 because it's not exclusive, or it's not included. So I have to say B plus 1 because we need to go all the way to B. Return num for range A through B plus 1. And I think that's it, because we're not doing anything else. Okay, just making sure. Cannot assign to a function call. I thought we could. Oh, return num for num in range. Okay, there we go. I just forgot that in area. Hi game friend. Let's see. Also doing this, since we're returning a list comprehension, this will definitely be I need to get back into it, talking about time and space complexity, but then doing this would be time of O of n, because we're iterating for every n nums that we get. So O of n, and then space wise it'll be O of It will be O of n because we're creating another list in space, and we're gonna go ahead and add that much n amount in there too as well. So this is what I am going to say, and that makes it more Pythonic to go ahead and write it in a list comprehension. Yeah, I have so many repos available. So yeah, add it in name range. So let's go ahead and try check it out. What's going on here? What do we get? What do we get? Okay, interesting. Okay, because you could identify the list like this as well and do the range from A to B. I'm trying to think, is that more Pythonic than the way that I did it with list comprehension like this? I guess you could have done this. Because range A through B plus 1 is already a function, and that will return you all the numbers in between, and you can just turn that into a list. I think that would be a lot faster than creating a list comprehension. I see. Yeah, originally I was going to do this, that say, hey, we're going to initialize an empty array, and then we're going to iterate starting from A all the way to B plus 1, and say, hey, keep adding in that num that we see, and then we're going to return the array. But with Python, you can do it a little bit faster. I like that. Return list, yeah. Arrange a B plus 1. B plus 1. Whoops. Okay, so now we're going to go ahead and move on to our 7 Caillou isograms. So an isogram is a word that has no repeating characters, consecutive or non-consecutive. So implement a function that determines whether a string that contains only letter is an isogram. Okay. So let's go and talk about our input. So we're going to receive a string of uppercase and lowercase letters. And then we need to return true if it is an isogram, else false. So an isogram is a word because whether assume the empty string. Oh, okay. So I wanted to make sure what to do with uppercase and lowercase. As you can see that from this example, moose right here, we're going to ignore the letter case. That means that we can go ahead and lower or upper the string, and then we can compare each letter. So an isogram is a word that has no repeating character letters. Okay. Let's see. Okay, what I'm thinking in my head is this will be a frequency counter pattern. And what was going to happen is we're going to initialize an object that will hold keys, which are the char, and then the value is how many times have we seen this character. And then, wow, because I'm trying to think, okay, so I would probably create that object first, and after creating that object, let's go ahead and check it again and see that if any of the keys have more than 2 for their values, that means we've seen it twice, then we can just return false immediately, else we'll return true. After creating counter object, yeah, it's a bit chilly this Friday. Well, for me, it is at least. So I hope Friday has been going well for you guys as well and staying warm. So hopefully everyone is staying warm. After creating, check if the value is greater than 1, then we're going to return false. Else, we'll go ahead and return true. I always want to say let object. Okay, but that's JavaScript. Object is equal, let's do frequency object. Well, in Python if we call a dictionary. So I want to make sure I use the right correct verbiage. So if we call a dictionary, and then we're gonna go ahead and say that for char in for char in string, and I want to go ahead and lowercase all the letters, so that's a fair playing ground for everybody, and we can go ahead and make sure that we count the correct letter, because an uppercase D is different from a lowercase d. So I want to make sure. It seems like here you're gonna ignore the letter case, so let's go ahead and do it like that. And then so we're gonna say the frequency of the char. Oh, thank you to your friend Richard. Oh, are they hanging out with you right now? Thank you so much. Yeah, no, I have heard that a lot from other people, and a lot of other people have said that maybe I should get into voice acting specifically for anime. So I'm open to it, letting the universe know. So if anyone is looking or interested, so yeah, I think that'd be so fun to do. Okay, so here, what's gonna happen? Oh, I see. Well, I appreciate hanging out with them and hanging out with me at the same time. I appreciate all you guys being here. Hopefully, you guys are staying warm. So, or at a cafe or something at least. Yeah, so we're gonna get char and we're gonna initialize it to 0, and then we're gonna say +1 if we have seen it already. So this, let's go ahead and just make sure it's okay. Perfect. So yeah, this is our dictionary, and then we're gonna say that for every letters you have seen, you're gonna print out the values and increment that. And as you can see here, it increments it if it's seen it already, so that's just 2. Perfect. And then now what we're gonna do is say that if any of the values, okay, so if any of the dictionary freak is greater than 2, we're gonna return false, else we're gonna return true. Some chars may not be adjacent. True should equal false. 1, 2, 3. 1, 2, 3. That is my fault. Greater than 2. That means that we're looking for anything past 2. I want to say that we're looking past 1. Okay, so that didn't work here. Okay, some chars may not be the same case. Interesting. What is this one printing out then? M0, 2, S is 1, E is 1. I think what this is doing is saying that for the first letter of that object or dictionary, if it's greater than 1, we're going to return false. But I want you to check every keys in that dictionary, because as you can see, this is returning false, which it shouldn't be, but I think it's looking only at M, but it should be looking at M, O, S, and E. Oh, I know, Elder. I gotta love these. Yeah, hopefully Fridays are chill. I actually think it's criminal to kind of have meetings on Fridays, but I totally understand. So, but yeah, let's see. Okay, so that means I need to iterate through each key in the dictionary to check that. And to iterate over a dictionary, I would say for keys that's what I would say. Let's do chars. If keys and chars, I have to make sure everything is indented properly. Otherwise, Python will break it for me. Yeah, I do hope the meeting ends quickly. So, oh, okay, that's right. Because this should be indented. So after everything has been checked, if it doesn't meet this condition, then it should return true. Okay, yay, it did work. My only thought is, can I simplify it somehow? Is there a method? I know that with Python, you can import collections from counter from collections, and what this will do, print, okay, let me print counter of string, and what the counter will do is is it import counter from collections? Import counter from collections. I'm pretty sure that's how you say it. Oh no, breaking everything, guys. Import counter from collections. From collections, import counter. Okay, I was kind of close. From collections, from this library, we're gonna go ahead and import counter. Okay, perfect. Oh, string that to lower. Because I do see that there's an uppercase, and I don't want that. Let's see. Counter of string. Return counter of string if greater than 1. Can I say that? We're gonna find out. Not supported by instances of counter and string. Okay. Okay, because I thought I could use counter string, and I'm just trying to think if there's any other method or any other strategy. Because it seems like even though I'm using the counter, one thing about it though is that it seems like I still have to iterate through it at every key in that counter. So essentially, I'll still be doing an O event loop. Although this is doing two O event operation, we drop the constant. We drop the 2, and overall it still becomes an O event operation. And since we're only returning true or false, the space complexity will be constant or linear. Sorry. Okay, so you see, we're iterating through every char, and here we're gonna go ahead and iterate through every dictionary. So that's doing O of N operation here, and then we're doing another O of N operation here. But that 2 of O of N, that 2 drops, and that becomes O of N itself. So overall time complexity is O of N. Space-wise, it's constant because we're only returning true or false. So it does not take up too much space. I'd be curious to see what others have created as well. Mid-M isogram. Did I break it? Sometimes code words work on me, but sometimes they don't. The length. You're right. Oh, okay. So they're comparing the original length of the string to a set of the string because you're looking at the unique values. Ah. Oh, that's true. I could have used a set because essentially what an isogram is unique. It only has one specific character of each. And I didn't even need to create a dictionary. Oh, string. So it seems like the string class has a method of count, and you can count for every letter that is greater than 1. I see. Yep. And so this is essentially what I was doing. Okay, so now that we know we can use set, the way, without looking at this right now, the way I would do with set, oops. The way I would do it with set is say return the length of the string, compare it to length of set of the string. Set of the string will convert it all into unique values. That's right. I was like, there's another thing, there's another situation here, but yes, we do need to lower all of the letters. Cool. Okay. So now we're gonna work on a 6 Caillou. So you probably know the like system from Facebook. So people can like and post blogs and pictures of others. We want to create a text that should be displayed to such an item. Implement the function which takes an array containing the names. So it must return the names, or it must return the display text as shown as below. Okay, so if it's empty, that means no one likes this. Otherwise, if it's 1, we're going to state their name. 2 people, Jacob and Alex. 3 people, we're going to state all of their names. If there's 4 people, you just only show the 2 names and 2 others, and whatever else is remaining of here. Okay. So we're going to receive a list of strings, and then we're going to return a string. We're going to return a string back of the list of names. So for example, if we have, just one list, and we have my, then I anticipate to say that my likes this. But if we have multiple people, my, rich, elder, friend. So then this one, since my and rich are shown in the first one, my and rich, and 2 others like this. Likes, like. Okay, likes this. Okay, so first and foremost, if to pseudocode this out, if the array is empty, return no one likes this. Else, if array has 1, return the name likes this. Else, if array has 2 people, 2, return name and name likes this. If array has 3 people, return name, and name likes this. Yeah, this one goes here. Otherwise, if array has more than 3 people, return the first 2 names, name, and however much remaining names like this. Okay, so the way I see it, I'm going to do it all into if statements right now. So I'm going to say that if not names, so meaning if names is empty, this is what it means. We're going to return no one likes this. if len of names is equal to 1, if there's only one name, if the length is only consisted of 1, we're going to return names of 0. Oops. I think F. Yeah, it's an F string. So in Python, to use a template literal, then I have to do an F string. So we're going to say that the name of 0 likes this. So this will grab the first name in the list. Otherwise, if the names is equal to 2, we're going to return here, similar to the above, name 0 and names of 1 like this. Leave len of names. If you are equal to 3 people, we're going to return f of names return. Okay, so 2 people like. I have to make sure like and names if len of names, else we're gonna say that we're gonna return so we're gonna say that if you are past 3 and you have like 16 people, we're gonna return the first 2 name and the len of names minus 2, because we already pulled out the first 2 in Alex and Jacob. So we're just gonna get the rest of the items in the array. Is it still there? Oops. I always do that with my mouse keyboard. I hope it's there. No. Okay. Pretend all my pseudocode was there. So we're gonna go ahead and write this out quickly. If not names, then we're gonna return. Sorry, excuse me for a second. Okay. Okay, so we're gonna rewrite all of this. Okay. So yeah, we have to rewrite all of this. So we're gonna return no one likes this. Elif len of names is equal to 1 or equal to 1. We're gonna check to see if it's equal to 1. Then we're gonna say return f of name of 0 likes this. Elif len of names is equal to 2. Then we're gonna return a name the name of 2. So this will grab our name at the position at the third leave. Else. Return. Do I still have it? Yes. Return. And the length of names -2. Oh no, I wonder if I broke it. Okay, so F of probably, is it because I use single quotes after when I was using double quotes? Okay, name 0. Oh, that is my fault. Names. Because we're referring to this names list. Okay, so Max, John, and Mark like this should equal to Max, John, and Mark like this. Maybe I need to make this a little wider. Max, John, and Mark. Okay, so I think what it looks like is just punctuation. Oops, not that. Punctuation, but the extra comma. Okay, so it doesn't like this extra comma either. Alex, Jacob, and 2 like this, and 2 others like this. There we go. Pat on the back, everybody. Pat on the back. So by doing this, I wonder, so like, yeah, I try to think about ways to optimize and simplify this. I could say that if the length of the name array is less than 3, then we're gonna go ahead and map through each names and say they like this. But my only concern is that likes and like here are different, so I would still do an if statements for all of them. And I'd be curious to see how others did it as well. Please let me know if you have any other thoughts on how we could optimize this as well. Add it in if. Oh, I see. Okay, so this person, you know, I understand how they did it like this, but for me to do it like that, I think I have to play with it more. Because that is really good. That is very good. I've seen this before. When you do a percent like this, I think it's supposed to stand for something dynamic. Very, very interesting. Very interesting. Hey, there's a case situations. Okay, so this is what I did. So you're gonna return an object. So this is the object, and you're gonna say the list comprehension. Min is 4. That is an interesting thought.